Hi, so today this video will explain about the time series data analysis, which is the stationary and non-stationary data. So we will first need to detect on what is stationary data and non-stationary data. So we have 7 content in this chapter. So the first one, it's what is stationary and non-stationary. So basically what stationary means is that the average of the data must be constant, the variance of the data must be constant, and the covariance of uh, the data itself on the future or on the past must be constant. So here is the raw data for inflation, GDP, export, and foreign direct investment. We would note this here that if we divide this data into different periods, for GDP, export, and FDI, its average would be different. Okay, for example, in the GDP, if we divide the data from before 2000 and after 2000, we will depict that its average on these periods is different. But the inflation, it might be seemingly similar. Okay, but we are not yet sure. We need to test for that. Here I use the first difference for every data here, and you can see that if we use first difference, then the data it's become more of in average point, more of in the center. In order to understand and then to test whether the data is stationary or not, we need to understand the stochastic process. And into easier one, we use the AR1, which is the first autoregressive. So AR1 means that this year, it's depend on last year. So from here, we can put that this year YT is equal to low 1 multiplied by YT minus 1, which is the last year. So this year have element of the last year by low 1, okay? And the low 1 can be less than 1. But we also can include the constant term, the alpha here, and we can also include the time trend, the t, multiplied by the theta. So if last year element is included in this year data, we will call it a random walk. A random walk means that low is equal to 1 completely. So this year data YT is equal to last period YT minus 1 and plus some residual, sum of the error term. This is completely random walk. So last year is completely equal to this year data minus plus by some element. And it's the same. The random walk we can include the constant term. We will call it random walk with drift. And we can also include the trend. We call it the deterministic trend. So what's the problem? If we use the variable which is non-stationary, in this case, if it's random walk, okay, if we use the data that it's random walk to regress with each other, for example, in this case, we use A and B, the variable A and then variable B. So the element of variable A is equal to itself last period, then multiply to some random variable or random error, in this case, V1. And then we construct B in the same way. So you will see that A and B, they are not correlated because their element is not each other. So here is the code to construct in the data. Now, after we get the data that is random walk, it's created by its own cell. The blue line, which is A, you can see that it's go by itself, and then B also go by itself. Here, when we do the scatter, not so much see some correlation or anything. However, if we might try to do some regression and then I use A depend on regression on B, we will see that the T statistic is statistically significant at 1%. Even though they don't have element of each other. However, if we regress the random walk variable, then we seemingly to have the statistically significant result. This problem we call it spurious regression. So we need to test for if the data is not like the random walk or in stationary in this case. So we can use the technique of AR1 again. So we look for only last year, whether they have some influence on this year or not. So like this case, we use the calculation from Professor Dickey and Fuller. We call it the Dickey and Fuller test. So by this step, at the end, we will see that the delta of YT will equal to this R1 and then multiply by YT minus 1. So here, if we use this calculation, we can also include the constant term and also the train in this equation. And by worrying about the serial correlation in this test, we can include the dependent variable of lag 1 year into the equation. So this is, we call it augmented Dickey-Fuller test. And what the result would be, then we can conclude whether the data is stationary or it's non-stationary. So from null hypothesis, we have the low one equal 1, and then alternative is low one is less than 1. So if it's equal 1, that means last year information include in 100% last year information include in this year information. If it's alternative, then less than 100% of last year information will include in the this year information. By using this technique, we need to calculate the t-test, the critical value into using this, and this is using from Davison and McKinnon. So here, we try to manually test for unit root, okay? And the difference of real GDP depend on like 1 year of its GDP. So this is the data that we need. And then I use train and also the like 1 year of dependent variable, which is to capture the serial correlation. And then also use the constant term, which is drift. But here we will see that this is 3.13 and it's statistically significant. However, we need to look at the appropriate critical value, which is this one. Okay, you would see that it's almost the same, minus 3.1. So it's seemingly like 10%. So this is quite not so strong evidence, but however, it's seemingly to have some result showing that there might be a problem of non-stationary or the unit root. We can calculate by using the automatic manual in the regression in the data. We can type D Fuller and then put the variable that we need to test. I include the option of train regress in order to show the regression result. And the last one is the lag 1 year, which is trying to capture the serial correlation. So here, the result is the same as we did manually before. So 0.8 and then t-test is 3.13. So from here, if this one, the statistic test 3.13, it's lower than the critical value, then we can say it's stationary. If it's not, then it's non-stationary, which is mean that we have a unit root. And when you compare here, you see that this is positive even, and this is negative. So it's not possible that this one will be lower than this. So then we say that the real GDP, the raw data on real GDP, is non-stationary, or it has a unit root. So here I exclude the trend, and also I test for the inflation. So after using inflation, you will see that this is minus 0.65 and t-test is 3.59. So the t-test is minus 3.58. And when we compare to here, you would see that this is lower than this one, 5%, but not the 1% critical value. So in here, we can conclude that the inflation, the raw data of inflation, it's stationary, or it doesn't have the evidence for unit root, and we have a confidence of 5% level. So we can say that the real GDP, it's they have a unit root, or itself become non-stationary, and inflation, there's no unit root. We can put I1 into notice of unit root or non-stationary by one level, one order. And I0 mean that there's no correlation or no unit root. So what happened after we detect that if it is I1? So if we regress the data I1 to I1, then we will get the spurious regression. Okay, so that means it's not the real impact. However, if both of them are I1 and we can test for co-integration, then we can do something after that. So this is the test for co-integration, and we have the null hypothesis and the alternative hypothesis. If the data it's here, I can use the same command in the data, but we use the error term for testing, and here is positive. Okay, here is I use the export here. Sorry, this one I test for export before we test for GDP. So we will see that if export is depend on real GDP or not. So I test for export, and export is also I1 because this one is higher than this. So this one is, it has a unit root. So after this, because both GDP and also export is I1, then we go for the co-integration. So we regress and then we predict the residual, and then we test for residual and its lag. And this is the result. The result here, the t-test is minus 0.53. So this is much lower than this critical value. Then we conclude that there's no co-integration between export and GDP. Okay, so if the dependent variable and the independent variable is not correlated, so what we can do after this? Okay, we might change the data to become I1 by putting first difference to the variable. It would help. Then we can use that into regression like ARDL model. However, if we test the independent and dependent variable to become co-integrate, so we can go with the long run estimation and the short run estimation. The long run estimation is by using the least square or the OLS that we used before. And if we want to detect the short run, we will use the ECM or the error collection model. Yeah, this is the way to go after we detect the co-integration. So this model, we will stop here, and thank you for watching.